So let's go ahead and look at another example. And I've written this example up here. We want to show that for every natural number, n cubed minus n is divisible by 3, and we want to be able to show this by induction. So we want to show n cubed minus n is divisible by 3. In case you've forgotten about the definition of divisibility, I've written it right here. A number m is divisible by 3 if there exists some other integer such that we could write that number as 3 times that integer. So that's what it means for a number m to be divisible by 3. So we want to show that this thing is divisible by 3 for every natural number n. So we basically have a propositional function that's claiming n cubed minus n is divisible by 3. And we want to show that that's true for all n. So that makes us think that yes, we're going to have to be using induction. So proceeding by induction on n, I have my definition right here. The very first thing I need to do is show my base case. Again, the base case here is going to be rather simple. We simply plug in 1 for a variable n right here and check and see whether or not it's divisible by 3. And I'm going to abbreviate div for divisible just because there's not a lot of room on this board here. So 1 cubed minus 1 is divisible by 3. Well, 1 cubed minus 1, that's simply 0, right? This thing is 0. Is 0 divisible by 3? Well, yeah, because by definition over here, all we need to do is to be able to write it as 3 times some other integer. And indeed, 0 equals 3 times 0 itself. So yes, 0 is divisible by 3, so this base case right here is true. So we've been able to establish our base case, and now we just have to move on to our induction step. So here in our induction step, what we want to show is that P of k implies P of k plus 1 for arbitrary k. And in this particular example, with this particular propositional function, what that means is that we want to show and here I have to be careful. On my left-hand side, I'm showing that P of k, so we plug in k for n. And on my right-hand side, I want to plug in k plus 1 wherever I see an n. So this will become k plus 1 cubed minus, and I insert in k plus 1 wherever I see an n. So what we're really trying to show is that if k cubed minus k is divisible by 3, then this expression is also divisible by 3. So for the implication, I can prove it in a bunch of different ways, but I'm going to use a direct proof. And recall, in a direct proof, what we do is we assume that our hypothesis is true, and we want to show that our conclusion is true. So this, on the left-hand side, that little p right there, that is our hypothesis. This on the right-hand side is my conclusion. So using a direct proof, what we want to do is assume the left-hand side, my hypothesis, and show my conclusion. So assuming my hypothesis, it says assume that k cubed minus k actually is divisible by 3. Good. So we've made that assumption. And now I somehow want to conclude this thing is divisible by 3. So let's go ahead and gather up all the information that we have so far from this assumption. So in particular, by my definition, since this expression is divisible by 3, That means I can write this expression as 3 times some other integer. Okay, that's all fine, well, and good. But how is that actually getting us any closer to showing that our conclusion here is true? Well, somehow we want to connect up this expression in our conclusion to something involving our assumptions. So let's go ahead and take this expression and study it a little bit more in detail. So I'm going to take this expression right here, and I want to study it and see if there's some way that I can connect up that expression with something that I have assumed. So what I'm going to do is I'm going to go ahead and expand this thing out. So if I expand this out, what do we get? Then I'm going to distribute my minus sign, so I'm going to get minus k minus 1. So, I have a plus 1 and I have a minus 1, so I know those are going to cancel each other out. Are we getting anywhere closer? Well, yeah, let's see here. We assumed that k cubed minus k is divisible by 3. And look at this expression right here. I have a k cubed minus k. So if I take this thing, I could rewrite it as that. So now I've isolated my k cubed minus k. Well, I've assumed, thankfully, that k cubed minus k is equal to 3 times some other number. So since I assumed that this is true, I can substitute in 3t for that expression. And so very importantly, this step right here is using my induction hypothesis. So I have made my assumption that this thing is divisible by 3, which is equivalent to saying this statement, and that allows me to then substitute in right here that. So this step right here uses my assumption, my induction hypothesis. And now we're basically finished, because take a look at this expression right here. I have 3's in front of everything. So finally, I can write the following. This thing is equal to 3 times and then t plus k squared plus k. So what I've been able to do there exists some number, that number right there. And so we'll make a note that that thing is t plus k squared plus k. Such that that left-hand side is equal to 3 times it. And that, by definition, means that this expression is divisible by 3. By our definition of divisibility. So, using a direct proof, by my assumption and a little bit of simplification, using my induction hypothesis right here, I have been able to show that this left-hand side implies that right-hand side. And so from my induction step right there, I've showed that it's true, and I can therefore conclude that this statement right here is true for all n. And so I can go ahead and just simply conclude. Taking just a moment, notice that this is prototypically how these proofs by induction proceed. So in your induction step, which is usually the most complicated, you assume your hypothesis, and then you gather all the information that you can about your hypothesis. So here I gathered the information that it was divisible by 3. And then what you do is you look at your conclusion and you see if you can relate back somehow your conclusion to that assumption that you made or the information that you gathered. And the way that we related it in this case was simply by expanding it out, canceling things around, rearranging it. So whenever you're doing this, you want to be thinking to yourself, how can I connect up what I want to show with all the information that I have assumed? And the way that I was able to connect it up was via expansion and a little bit of algebra. That is usually how proofs by induction proceed.